It's 11:20 and class has started. Good morning, everybody. It is awful outside. It is wet. It is rainy. It is windy, but here we are. Zach, if you could go ahead and put your last name in, I'd appreciate that. So that way you can be counted for attendance. Okay? So today, guys, we're talking about inverse functions. No one told me that the audio wasn't working on my videos, and so I think that my audio is working now. And here I'm just going to do a little sound check for myself. Okay, it's working. All right, excellent. So videos will have sound now, and everything will be good. So I hope you guys are doing well. I hope you're safe. I hope your families are doing well. Thank you, Zach. I appreciate it. And yeah, I'm just glad to be here. I'm glad to be doing math with you guys, and I'm glad well, hopefully everyone's doing okay. So, all right. So let's go ahead and take a look at inverse functions. So let's talk about inverse notation. Okay, so inverse notation is kind of confusing. So if this is f of x is the function, okay, then we go f and then to the -1 is the inverse function. Okay, so that is our notation. Now notice how that can be confusing, right? Because it's not, right? So it's not this, right? Okay, because this just means you flip it. So notice how it's with an output, right? So this is an input. And notice how it's with the function letter. We would never write it up here, okay? So the -1 goes here. That's how we know it's an inverse versus an exponent, okay? So don't do that. This does not mean the reciprocal of f of x, okay? So I just want to make that really clear. This is not the reciprocal. This is the inverse, right? Not the reciprocal. I just totally misspelled reciprocal, and I feel a little sheepish. There we go. Oops. There we go. That's an R. Oh, I'm just gonna try again. Reciprocal. Okay, not the reciprocal. Okay. All right. So that's what we got for notation. So moving forward from that, what are we doing next? Okay. So again, it's not the -1 power. It's not a reciprocal. It's an inverse function. We write it with the function. Okay. So just make sure you guys know that. All right. Cool. Next up, what is an inverse function? So you guys might have been talked about inverse operations, right? So inverse operations would be, what's the opposite of adding? Subtracting. What's the inverse operation of multiplication? Division. So functions also have the inverse. So we define an inverse function to be when you can take the composition of two functions and get x, and you can switch it around and also get x. Okay, and I call this the foot and shoe. And shoe rule. Okay, so what do I mean by the foot and shoe rule? So this is what I'm going to do here. I'm going to transition. All right, so I got a shoe, right? It's a Brooke running shoe. I know you're mad jealous because I run. All right, so think of this shoe as a function. Now, really, the shoe is two functions, right? So for the shoe to work, we either put it on or we take it off, right? Now, this isn't my foot, but you can think of this as my foot. My foot is the input. I'm literally putting it in. Does that make sense? So my hand is the input. Okay, now there's two things that are happening here. One, there's the function where I put on the shoe, right? So I put my input into the function, and now it's a shoe, okay? And what I get out, hopefully, is some sweet running, okay? Now, when I'm done running, there's an inverse function, and the inverse function is I take out my hand, ooh, and the shoe goes away. Now, the important thing here, because I want to make sure this magic trick works, for it to be an inverse function, that means when I do both functions at the same time, I should be left with my input. Okay, so does that make sense? So the idea is that inverse functions are defined by if you do both functions as a composition, that is both functions at the same time, you should be left with your input. Okay, now I couldn't do that with my foot. I normally do that with my foot. Okay, so this is the foot and shoe rule. The idea is you know two functions are inverse functions if when you do composition, and it doesn't matter both ways, you don't need to do both. Yeah, I should write that down. Do not need to do both. Okay, so what that just means is do the one that's easiest, right? Because who am I, like, going to be doing all this hard work, right? Okay, so you do not need to do both, but it's going to be true for both, okay? So it's the foot, I call it the foot and shoe rule. That is that if they're inverse functions, you should be left with your foot if you do both of them at the same time, okay? So let's do an example of this. So let's say that f of x equals 5 over x minus 2. Okay? And let's say g of x equals 5 over x plus 2. Okay? So we're going to test, the book calls it, we're going to verify if they are inverse functions. All right. I know you guys are super excited, right? So, it doesn't matter which one I do. So I'm going to do f of g of x. Okay. I said I was going to do a review of composition. So I'm going to do f composition g of x, which is the same as f of g of x. Does that make sense? Okay, because I know some people are getting stuck with composition. These are the same thing. Okay. So then all we're going to do here is we're going to say, okay, what's g of x? G of x is, so this is really f of 5 over x plus 2, right? So g of x is literally this, so I can just substitute them. Let's get a different color up in here. Okay. And then once I get here, okay, so now my input is this. So anywhere I see an x, I'm going to put this, right? So f of x is 5 over, and then where I have an x, now remember, whenever we substitute in, we put parentheses. So I'm going to have 5 over x plus 2, and then minus 2. And see, wherever I had an x, I'm going to put this. So I'm just down here, I'm going to make a note. Do you guys see how this used to be x and f of x? Okay, so I'm just replacing my input with my new input. Okay, so now what we're going to do is we're going to simplify. Okay, so to simplify this, first of all, I got plus 2, minus 2. Those cancel out. So then I have 5 over x. Now, if you're like me, this causes a headache. It's like, multiple fractions. So just remember, when you're dividing a fraction, you're really multiplying by the reciprocal. So this is really just this. It's 5 times x over 5. Okay? So again, when you divide fractions, you're really just multiplying by the reciprocal. So you just take your second fraction, flip it, change it to multiplication, and your life is easier. Because what we see now is, when you do this, the 5's cancel out. Okay? And we get f composition g of x equals x. Or your foot. Okay? So f of x is kind of like putting on our shoe. G of x is like taking off our shoe. So at the end, if I do both, I should have my foot left. That would be really awful if you put something in and you did the inverse function and what you put in disappeared, right? That sounds like someone's trying to scam you. Wait, why negative 2? Because there's a negative 2 right here. Right? So it's f of x equals 5 over x minus 2. So the negative 2 comes from the f of x. Okay, so that's why there was a negative 2 here, because it was part of the original function. Okay, so I think people are getting confused with this, so I'm going to go ahead and do an audible, and I'm going to do, we did f of g, so now let's do g of f. Okay, so again, I'm going to write down the functions because I had to switch pieces of paper. So f of x equals 5 over x minus 2, and g of x equals 5 over x plus 2. Okay, so we're going to verify. So to do that, we're going to do g composition f of x. Okay, so again, you don't have to do both. I'm just doing this because I think some people need it. Okay, so don't freak out there. So if we do this, this really is g of f of x. So the first thing I'm going to do is, well, what is f of x? F of x is this. So this is really g of 5 over x minus 2. Okay. And then what I'm going to do, everywhere I see an x in g of x, I'm going to plug this in. So I'm going to get 5 over, and then my new input. Okay, and then plus 2. Okay, so again, right, it's g of this, so anywhere I have an input in g, I'm going to replace it. So remember, this right here used to be x for g of x. Okay, so now we're going to go ahead and we're going to simplify this. So to simplify this, it's a fraction over a fraction. So the easy and quick way to do that, whenever you have a fraction divided by a fraction, take the second fraction, flip it, and change it to multiplication. That's just called multiplying by the reciprocal. So I have 5 times x minus 2 over 5. You see how I flipped the bottom, change it to multiplication? Well, here I go multiply by 5, divide by 5. And then I have x minus 2 plus 2. Those go away. And check this out. G composition f of x equals x. And guys, that's all there is. So we can say g of x and f of x are inverse functions. Okay? You don't have to do both. You just need to do one. So don't do both, just do one. G and f of x are inverse functions. Okay? All right. Okay. So, so verifying an inverse. If you don't get x, then guess what? They're not inverses. All right, cool. So either you get your foot or you don't. And if you don't get your foot, then that sucks because that was your foot. All right, so sorry, I'm not showing an example of that. I just thought it was funny. I thought of amputation. Amputation isn't funny, but all right. So inverse graphically. Okay, so an inverse graphically is, so all inverses are just a reflection over y equals x. Okay, so throw back to geometry, right? So it's just a reflection over y equals x. And guys, this is super important. If you know this, you can do any inverse. And students always get stuck, and I'm just like, well, then you didn't understand this, right? It's literally just y equals x, right? And we'll get more into this for a second. So here's an example of this graphically. Okay, so I might have a graph here that we can just make it look like whatever we want. Okay, and then I graph y equals x. Let's call this f of x. Okay, then what happened to all my pens? Okay, then I'm gonna do the best I can here. Oops. All right, that's okay. This would be f inverse of x. Okay, so and you guys talked about this in geometry, right? D1 and D2 are going to be the same. Okay, because you're just flipping the x and the y. Now, to do this in more of an algebraic way, let's say this point is a and this point is f of a. Okay, then that means that this point over here, that means that this is a and this is f of a. So the coordinate for here would be a f of a, and the coordinate here would be f of a. Now that brings us to our next thing. Look at these 2 points. Do you see how the inputs are switched? The input and the output are switched? That's because y literally equals x. So the x here is now y, and the y here is now x. And if you get that, then you understand inverses. All an inverse is you literally just take your x's and make them your y's, and you take your y's and make them your x's. So this point here is at a f of a, and then this point over here is at f of a. So remember, this is your x, this is your y, this is your x, this is your y. Do you see how your x and y's are switching? Oh my gosh, so cool. That's it, guys. That's it to an inverse, okay? And if you know that, you know how to solve them, you know how to identify them. You can identify them in a graph, in a table. You can do it algebraically. This is the key knowledge to everything, okay? So the y and the x switch in inverse functions. Okay, that's the key takeaway. Okay, so I try to do it a little visual. Hopefully that helps. No one's saying anything, so that either means that my internet's down or you guys all died, and I will die soon because the tidal wave is not in Bellingham yet. Okay. Kind of terrifying, isn't it? All right. So let's keep going here. Okay. All right. Okay. So here's another example. Okay. So if I have a table, and this might help you in your homework. Wink, wink. Okay. So let's say I have x and f of x. Okay. Let's say I have 1, 2, 3, okay, because I don't want to get too complicated, and I'm just gonna, just do some. Oh, you guys are still alive. That's neat. Okay, all right, that's good. Good to know. Good little visual there. So let's say this is like 7, 8, 10, and 12. So, and we'll talk about this a little bit for us. So this is right. We have every input has one output, so it's a function. So then, what if I wanted to add a box here? But in this box, I wanted to do f inverse of x. Okay? No, this is going to be too complicated. Let's draw a new box. Okay. So if I wanted to do f inverse of x, so it'd be really easy to do this, right? Because literally x and y switch. So I can just go like this. Boom! I made a table for f inverse. Do you guys see how they switched? And I guess I didn't have to erase this. This would be, the output would be 1. No, I can't do that. Yep. I was right to erase it. I was right to do this. Boom, 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 boom. Okay? Do you guys see how I just created a table for f inverse, and all I did was invert the x and the y? Okay? So, you can tell, so if you're given 2 tables, you can tell that these are inverses because literally the x and the y's were switched. Okay? So that's it. So again, the x and the y's are being switched. Okay? So in your homework, it's going to be like, hey, it's going to give you 2 functions. It's going to be like, hey, this is h of x and this is g of x. Are they inverses? And you're going to be like, well, yeah, all the inputs and the outputs are just switched. So yeah, they're inverses. Okay? Yeah, you guys are going to be golden. You're going to be so gold, you're going to want to stop by the bank after this and maybe cash yourself in, you know what I'm saying? Because, yeah, that was a bad one. All right. Okay, so now let's talk about 1 to 1 and the horizontal test. Am I going too fast? Are we doing okay, guys? Just picked my nose on TV, so I hope that you appreciated that. I did that for you. Okay. Okay. All right. So 1 to 1 horizontal test. I mean, hopefully this stuff is all review. So Next class, are you guys excited for this? Next class, we're going to start our first lesson, woo, which is mostly review, but I'm pretty excited to get back to teaching. Brandon, I don't know if that sad face is because we're going to be learning new stuff or because I picked my nose. So I'll just do it again for you, just in case it was the nose. Okay. So one-to-one horizontal test. So what's one-to-one? One-to-one. Okay. That is the requisite. So it has to be one-to-one. So two functions have to be 1-to-1 to be inverse functions. Okay, so what does that mean? That means for every input there is one output. Now, for those of you that are paying really close attention, for every input there is one output. That's the definition of a function. So what makes this different is this word, and. Okay? For every input there is one output, and for every output there is one input. Okay? For every input there is one output. For every output there is one input. That's why we call it 1-to-1. Haha, do you see where the name comes from? Okay, so that's why it's called 1-to-1. For every input, there is one output. This top one, that's just the definition of a function, right? But this bottom one, that is for every output, there is one input. Okay, so it goes both ways, right? Now, this is going to confuse some people because it's a very thin line about what I'm talking about. So what I'm talking about, this is for an inverse function. Okay, this is for an inverse function. You can have an inverse not be a function. Oh dear, right? So so an inverse doesn't have to be a function, but if you want it to be a function, then this has to be true. You have to have 1-to-1, okay? UWU, you would you what? I don't know what UWU means. University of Washington? No, I don't know. Okay. I'll have to Google that. Apparently, I'm not hip. Okay. So next up, let's see what we got here. Okay, horizontal test. Okay, this is how we test 1-to-1 on a graph. Okay, so this is how we test 1-to-1 on a graph. So let's do two examples here. Anybody know what the parent function of this is? Oh, you were just doing like the mustache, like okay. Yeah. So if you guess polynomial, then you're good to go. And if you're wondering what we're doing in chapter 2, polynomials. What? Crazy. All right, cool. So if I want to do the horizontal line test here, all I'm looking for is that there is one point that touches the line. Now, wasn't that a lot like the vertical test, right? So the vertical test only tests to see if it's a function. The horizontal test tests to see can it be, right? Can it have an inverse function? Right? That's the question. Can it have an inverse function? So here, can this have an inverse function? Yes. Okay. Cool. That was really boring, right? Okay. All right, so let's do another example. Okay? So let's do an example of this one. Okay, and you might be like, ooh, another polynomial, correct? Right? Specifically, a quadratic, right? So now with this one, there are 2 spots. So no, it is not. It cannot have an inverse function. Now, I really hope people are like losing their minds because you're like, correct, right? This is a quadratic. The inverse is a square root. How is this true? Ah, it is true. And this is where we need to talk about the difference between an inverse function and an inverse. Okay? Because if I were to, now you guys ready for this? Let's do one more here. I'm going to draw this again. Why did I make it so difficult? But this time I'm going to draw in, and I just need to, so this is y equals x, right? All right, oops, can't see it. Okay, and then I'm going to just, it looks like this. Okay, is the blue graph a function? So is this graph a function? And no, it's not. In fact, right? In fact, what we do is we go like this, right? We only take the positive, because if we take the positive, is that a function? Yes. Oh, so it turns out that a quadratic like this actually can't have an inverse function. It can have an inverse, but to make it a function, we have to do something, and we have to put a domain restriction on it. Okay. So if it fails the horizontal test, if it fails the horizontal test or the 1, 2, 1 test, okay, then it does not have a inverse function. But we can still, that's too much writing, I need to slow down. Okay, if it fails the horizontal test or the 1-to-1 test, then it does not have an inverse function. That's the big takeaway, okay? But we can still find the inverse, right? Because we've been finding the inverse of x squared now for a while. We can still find the inverse with domain restrictions. Okay, sorry, that was a lot, wasn't it? Okay, so again, reading this. If it fails the horizontal test or the 1-to-1 test, then it does not have an inverse function. Okay, but we can still find the inverse with domain restrictions. So think about really quickly. Think about f of x equals x squared, and g. Okay, so just think about that. Oops, think about that. Okay, the actual inverse of this is plus or minus the square root of x. This is not a function. Okay, so what we do to be able to take the inverse, what we do then is we say, okay, the inverse, we say, is the square root of x, right, where the domain has to be greater than 0. Okay, so do you guys see how this isn't a function, but what we do here is we put a domain restriction on it. Okay, and this is how you learned how to do squares, right? Your teacher always said, like, we only want positives, right? But with the plus or minus, this isn't a function. Okay, so I hope this is helpful and not confusing. I'm just trying to really break it down for you guys. Hope this helps, because you guys don't really communicate. So, all right. Okay, so we've done all of that. Okay, so now let's get to the part that is really important, and that's finding. You guys still don't talk. Like, are you guys doing okay? Hello. Hey, everybody. Okay, find. Sup? Yeah. Hey, guys. Yeah. All right, find find the inverse algebraically. I'm like, yeah, guys, you should be typing, and then I start writing things down. Troll teacher, huh? Find the inverse algebraically. My handwriting could really use improvement. All right, find the inverse algebraically. Okay. So this is the part where I'm anticipating. So the concepts are super important. If you don't understand an inverse, then you're not actually learning. So that's why I spent so much time on just what is the concept of this. So, oh my gosh, time's flying. So I'm going to try to get through this in 2 examples, and hopefully we'll be good to go. So if we need some extra time, we might have to take that. Okay, there's 2 ways of taking inverse algebraically. In our class, we're almost exclusively going to be doing the first way. Okay. I know, Monica. I'm sorry. I'm a troll. Okay. So so the first one is when you have a function with input and output. Okay. So in our class, this is what we're going to be doing. I just want to make super clear. This is what we're going to be duping. Okay, so if you remember, I don't know why I choose that. If you remember what I said, all we're doing is first, oh my gosh, we're going to switch the x's and y's, and then second, we're going to solve for y. And then third, we're going to replace y with f inverse of x. And the reason why, so you can just replace y at the very beginning with f inverse of x, and you can see books and YouTube videos and teachers do that. But guys, I'm so lazy. I don't want to write this a whole bunch of times. This is so much easier to write. So what I do is I just replace it at the end. Now, the only downside to my way of doing it is that you can't forget to put back, you can't forget to do the f inverse notation at the very end, okay? So just remember, I choose this method because it's faster. I'm lazy. You just can't be too lazy and then forget this at the end, okay? So what we need is some examples, okay? So let's do a couple of examples together and then see how we're doing. So we have f of x equals 5 minus x over 3x plus 2, okay? And we're going to find the inverse. Okay. So to do this, okay, first remember this right here, isn't this just y? Okay, so what I'm going to do is I'm going to switch my x's and my y's. Okay, so this is x, and then I have 5 minus y over 3y plus 2. Okay, so I switched my, so this is my y, right? So I switched my y's, I switched So now I have to, okay, now I have to solve for y. Yeah, I'm so excited. Thank you, Kraft. All right, so first let's get rid of the bottom, right? No one likes fractions, so which you should totally love fractions. Let's go ahead and get rid of the bottom. So I'm going to multiply both sides by 3y plus 2. Okay. So let's see what we get. We get, now remember you have to do parentheses because this is going to be distributed, right? Okay, so I'm going to have 3xy plus 2x equals, these cancel out, 5 minus y. Okay, now all these problems are most likely going to be the same. We want to get all of our y's to one side. I feel like Algebra 1 teacher. I want to get all of my y's to one side, all of my non-y's to the other side. So the first thing I'm going to do is I'm going to get all of my terms to one side. So this is negative, so I'm going to get my y's to the left, and I'm going to get everything else to here. So this term has a y in it, and this term has a y in it. So I'm going to add y to both sides, and then I'm going to subtract 2x from both sides. Look at me doing 2 steps at once. Okay. So what do I end up with? This stays, so I get 3xy plus y equals 5 minus 2x. Yes, I'm taking a break. Oop, it's way too bright. I gotta close my blinds. When you're a vampire, you gotta look out for that natural sunlight, you know, or else. All right. So here, so what I did is I got y's to one side. Okay. Now here, what I'm going to do, if you end up with multiple terms with y, then we're going to have to factor out the y. Okay. So let me do that for you. Okay, so we're going to factor out the y. So see how I have a y in this term and a y in this term? I'm going to pull it out. So what am I left with? 3x plus 1. And remember, you can always just go backwards. If I distribute this y, shouldn't I get back to here? Okay, so sometimes you just have to guess and check. But remember, guess and check is slow, so the faster you can do it, the better. And then I get 5 minus 2x. Okay, so all I did here was I factored out the y. And then once I do this, hey, I only got one y, so check it out. This is y times all of this, right? Okay, so I'm just going to go ahead and divide. Okay, that goes away. So I get y equals 5 minus 2x over 3x plus 1. Now, I was going to have it where I was going to plug that back in and test it, but I don't have time to do that. So, but, ooh, you know what I didn't forget is that last step, right? Don't be lazy, Kraft. This is S inverse of x equals 5 minus 2x over 3x plus 1. Okay, don't forget, don't be like Kraft. Don't forget to do the end part. Okay, so yeah. Gosh, that was a lot, but it's just a lot of algebra, right? It's just moving stuff around. So remember, okay, what we're doing here is first we switch out the x and the y's. We solve for y. Sometimes if you have more than one term with y in it, you're going to have to factor. Hey, factoring is always going to help work with getting those y's out. And then just get y by itself. Okay, don't forget to go back to f inverse. Okay, cool. All right. Hey, the second situation is when you have defined. When you have defined variables. Okay, we're almost, oops, sorry, when you have defined variables, we're almost never going to use this in the class, but you need to know it because science uses this, right? So let's say I want to go from degrees Fahrenheit to, or no, the other way around. Let's say I want to go degrees Celsius to degrees Fahrenheit. Okay, those are defined letters, right? C is not an input. F is not an output. So when I write Fahrenheit equals 9/5 Celsius plus 32, okay, there is no input, there is no output. Okay, these are defined variables. So I would just solve for C. Okay, that's it. Okay, so I would subtract 32 and then multiply by the reciprocal. Okay, we aren't going to be doing these. This is more of a science thing, so we leave this to science. But I just want you to know, in science class, don't be like, that's not how you do it. Kreft told me how to do it. He's never wrong. Okay, so just want you to know, if they're defined variables, you just solve. Okay, you don't have to do the switch thing. Okay. All right. Hey guys, we're supposed to be done. What time are we supposed to be done? 12:10 or 12? You guys are done at 10. Oh, 12:10. Okay. Good. So we got 10 more minutes. Okay. So we probably should do one more algebra one. Let's do one more algebra one together. While I'm waiting, does anybody have any questions? Are we doing okay? You guys make me feel nervous because, you know, math. All right. So we're going to find the inverse. Okay, and this one's going to have domain issues. Right? It's kind of like having mom and dad issues, but with math. Okay? Notice how I didn't say find the inverse function, right? So what are we going to do when we have domain issues? Okay? So let's do this. F of x, we're so boring. G of x equals the square root of 2x minus 3. Okay. So we're going to find the inverse of this. And we already talked about square roots and squares, right? So it's going to be interesting, isn't it? It's not that hard, guys. It's really easy. Okay? So we're going to solve for the inverse. So remember, this is just y, right? Okay. So what's the first step? First step, I have y equal, okay, I'm just going to rewrite it. It's not what I wanted to do for my first step. Okay. First step, I'm going to switch the x's and the y's. So what's my first step? So I switch the x's and y's. I wish my math teachers in high school told me to write down like why I did my step, because I'd always look back at my notes and be like, I have no idea what I did, right? Write down your reasons, right? So that future you can figure out what's going on, all right? Because present you doesn't get it. No, I'm just joking. Okay, that's weird. See, when you guys don't talk to me, I just get weird. I get it in my head. All right, so I'm going to solve this. So the first thing I need to do is get rid of the square root, right? So I'm going to square both sides. Okay, so I get x squared equals, those go away. These are all positive, so we're okay. Okay. And so here, this is, okay. Then I'm going to add 3 to both sides. And then I'm going to divide by 2. And this is just solving. So again, I added 3, divided by 2. And then we're good. So the last step, right, is to switch out this for g prime. So I'm going to say x plus 3 over 2 equals g prime of x. Now, if only everything in the world was so simple. Because we did all of this, and we didn't talk about domain. So, when you're doing inverses, this is what you do. Go all the way, okay, because the algebra we wanted, right? So what was this? This was replace y with function notation. Okay. All right, let's go back here. The key here is we're going to look at our domain and range. Okay. So, to look at domain for this one, see how my horizontal dilation is not 1. So I'm going to have to factor this. So this is really 2 times x minus 3 halves. Right? And you can always, right, you're going to multiply everything. So the opposite of multiply is divide. Okay? So take a look at this. So for the domain, normally it's at 0, 0. But I'm shifted right 3 halves, right? Okay? Because this, if this is, think about it, 3 halves. 3 halves minus 3 halves, that's 0. Times 2 is 0, right? So 3 halves is my shift. Kind of cool, right? If you know transformations, you can take the world. All right, so my domain, I know that it has to be 2/3 or greater. Okay. And my range, now with the range, there's no vertical dilation, there's no vertical shift. So my range is going to be my same range as square root of x. So all I know about that is that the outputs aren't negative. So I just know it's going to be 0 to infinity. Okay, and this is for g of x. Okay, so what happened to the x squared? Oh shit. Okay, and of course I'm recording it now. Sorry, swearing's bad. Don't do swearing. Edwin, and, oh, sorry, I shouldn't say names. A couple of people really, I'm so sorry. Yeah, there's a squared in there. I'm so sorry. There's the squared stays. I was so focused on everything else. Yeah, super minor thing. The squared stays through. I'm so sorry, right? So this is, if you take a look at this, it's a quadratic that is dilated by a factor of 1/2 and shifted to the left by 3.5. Okay, I'm sorry about that. Does that help everybody out? I'm so sorry. The x squared just goes all the way through. It's really not that big of a deal. You could have lived your life without having that, but it is important because in math you're either right or wrong. So, all right. So, is everybody okay here with the domain and range? All right. So now let's go down here. So, did you remember what I spent the vast majority of this class talking about? An inverse, what does an inverse do? It's just what? Right. I want to give you 10 million Kreft points, but I don't even know what Kreft points are, so it makes it harder to give it to you. So think about this. Domain and range. Isn't this what works for my x and what works for my y? So my inverse function just switches my domain and range. So my domain is my old range, and my range is my old domain. Okay, they just switch. So that's really good news, right? Because if they just switch, if you put in all the time to get your original domain and range, then you're golden, you're set, you're ready to go. They just switch. The x and y's just switch. And if you think about that, right, if I write this out in more of a standard notation, this is just why can't I do this? That's not what I meant to do. This is 1/2 x squared plus 3/2. So, so think about it. Did I do that right? Oh my God, guys. I can't believe you made me do this. I wrote 2/3. So you can see it's just x squared shifted up 3/2, which is why the output is shifted up 3/2, right? That's what's going on, okay? All right, so that's why it works, right? So you guys know that it's shifted up 3/2, and this should have been 3/2, right? Because this says 3/2, not 2/3. Jeez, guys, I'm making a ton of mistakes. But it is 12:11, so I do have to end class. Did I get through everything? Yep, I sure did. All right, guys. So if you need to take